Okay, in order to completely understand this project, I had to put together at least a rudimentary model of the parts we were working with. And I was trying to find a closer example of what actually could occur at your place with it attached to that cantilever overhang. I couldn't really find that, but I tracked down some other information which essentially confirmed what I thought. Once I put together a reliable model and dimensions, I tested all of those members that are now being used for the deck system. But all of those members passed. And these are the floor joists, and this is even if the deck load were able to be somehow applied to that band joist at the end, these members could still handle that load. But there's no reliable hardware or anything to attach that reliably to that band joist. And so your choices, are going to be limited to coming back onto this wall or adding some sort of a beam out here. The deck floor beam passed pretty handily, and that automatically tells you what the loads are on these columns coming down to these locations here. So, and then these are calculated by the amount of those loads, 32, 85, etc. So these are the minimum kind of footings that hopefully are already in place for these 5 columns here. And if they're bigger than that, we might be able to do something creative. But there's no reliable way really to measure those now that it's been there for so long. There's 0 cracks, right? So I didn't actually take a note of that, but it seems like that concrete was pretty stable, so maybe let me know if that's cracked. Now, based upon, I did not take this measurement here, but based upon what it looked like to me, which is about 3 feet, and we can double check that, these are all good measurements here. So this is the loading on each of these columns. And I tested each of these members in the member sizing program, and all the members pass, including this beam down here. But you and I discussed the issues with that beam where they've spliced that together. So my feeling offhand is that this beam should be replaced anyway. Maybe these members can be reused somehow in the plan. And I think that I don't think these are from 1969, these floor joists. I think at least these floor joists have been replaced at some point after that. So I think these floor joists, to the extent that they're attached to this ledger board, are okay. But this beam, I think, should be replaced, and I think these columns should possibly we should try to endeavor to just do a column here, and a column here on these existing footings. And we will assume that they made all these footings 18 by 18. But these are the minimum size footings required. This is the load on each of those columns from my beam sizing program. And this would be the size footing required. And this kind of makes sense. This is the edge of that existing slab here. This line here. And so if that's 18 by 18 as required by the load, it'd have to be located back, something like that. So that's another issue, exactly what they have down there. Maybe they have just poured a whole wall that's 32 inches deep of concrete. But the only way to really know that is to excavate this some. So for now, though, obviously this has been reliable so far. This 5-point bearing has been reliable so far for this beam. So whether we replace the beam, the columns, or whatever, we can rely on that much. And your 2 choices back here are, as I covered in the earlier part, with regard to either going back in here with them or adding another beam back here between these columns. But the problem with adding another beam back there at the columns, now these footings won't have to be as big, because it's only carrying half that load according to the calculations of the program. This one's carrying 400 pounds a lineal foot, and this beam back here is only carrying 200 pounds per lineal foot. So presumably we could get by with, a column here, and this concrete could be cut. It was already been cut for that one, so it's cut again, and a footing is put in there, and this concrete is cut again, and a footing is put in here, and then we get by with one more in the middle. I haven't tested that to see what that is going to be required if we did it that way, but otherwise it is extending either new joists or these joists here back to this wall and then closing that off again. And I was going to put together a couple diagrams to show you what I meant, but when I started just looking up things to see what the problems were with this, which they're obvious, and that's why the last 3 versions of the code haven't allowed it. And so this is what they say, that has to be supported by something, which means one of 2 solutions for your particular thing. A beam at this end, separate from the house, or what we talked about when I was out there, where you run joists back to this wall, but you have to take off this band joist, that existing band joist, which means somebody has to saw along here and cut off the nails from that wall up there. It's a little easier because you just have plywood up there right now, and part of that could probably be removed to help do that, but certainly that makes a more open area underneath. And I don't know if a person would be inclined to, I guess these floor joists are 30 or 40 years old, so I guess a person wouldn't be inclined to reuse those. And if they were inclined to do that, and speaking of maybe needing a new beam, these ones fairly new up here, and I have to tell you, I see zero reason for that. And I could run that by an engineer that probably charges, I don't know, a couple $100 or whatever. But these 30-foot long, 16-inch high LVLs, which has to be pretty expensive, I really don't think those are needed. And I don't even know if that, I don't have those plans again that I can read close enough for that, and why that would be specified. But even if there is a question of thrust on that wall going outward, a cable would suffice. Certainly a cable or anything like that would suffice. This is, maybe you can reuse those if you want to take them down, if you're inclined to take them down, particularly if this deck is extended out further under here, so you don't have that point of division. But it is something to think about, so I'm running it by you. So in the event you were not interested in extending these joists over this wall, I began to design a beam back here as what I talked about. And actually when I did that, because as I said, that load is less than what's at the front end, and we were able to do that, or I was able to do that with 3 2x10s with just one center column, which meant these loads were coming down on either end, but those loads at the ends are fairly light. And so I called Simpson Strong Tie, and they make this hanger here is the one you would use. You can use that at these ends. This is your, pretend this is your 6x6 column that's coming down, that existing column for the roof, and I'll explain that in a minute. That's coming down on its existing footing, but that footing is well oversized, and that footing can easily handle this additional 1,300 or 1,400 pounds hung from this hanger. And that hanger is right here, and you have to use nails. I called Simpson and asked about using the screws, but they want you to use these nails, which it looks like 16 penny nails in each of those hangers, but that gives you a load rating of 2,300 pounds or 2,000 pounds, and ours is only 1,385 or 1,400. So we don't have to put new footings back here and here, and we can just, this will end up being a triple 2x10 suspended from that column and that column, and we will have to have a new footing here in the middle and a new column in the middle. And what I said that I would explain in a minute is, once I thought that maybe this would be a possible solution, I also designed that truss that's over the deck now, those trusses that are over the deck now with their loading. I mean, ignore this, it just comes down to how much of a load is coming down on that beam C up there on your deck, your roof beam. And that's, so this, all that truss load is transferred to that thing up there, and they have two 14-inch LVLs. That could have actually been done with two 2x12s according to this program, which is, you know, pretty reliable. So that could have been done with 2x12s instead of those 14-inch LVLs up there. But the upshot of all of that is that the load coming down on each of those 6x6 columns, and that's at all four of those 6x6 columns, that load is only 2,270 pounds, and a load of 2,270 right here really only requires a 15-inch square footing. But they have put, and it's documented and inspected, they put a 24x24 footing in there. So that is easily going to handle our additional, we'll say 1,400, 2,270. It's in an additional 1,400 pounds, and they still only need a 19-inch square, and you have 24-inch square. So we can definitely hang that new beam here and here. There's nothing that's going to go across that whole length, that's, unless it's like your 16 inches up here, that would go across that whole length. So if you do decide you can live with the central column, you can get by with 3 pieces of 2x10, and there's your central column, and the load on the central column is around 3890. So that footing for that central column really only has to be 12 inches square. So there's not a lot of load at where you would need this, you know, center column here and center footing. So you would end up needing a, you know, a small footing here, and I would just say, you know, cut out 16 inches of concrete and then dig down to 32 inches and pour it that way. So if you go with this additional beam back here, this is what you end up with on your plan, essentially, where all these joists will need to be cut back a couple inches, because these are just used joist hangers against the new 3 2x10 beam that comes across there. And if we go to this section, elevation 2, looking this way, this is that existing beam out there and that existing 4x4s, and you have 90 inches under it. And if we use these 3 2x10s, and there's a hanger against a column there, and then a column and a footing in the middle, and a hanger at the other end, you end up with about 94 inches to the bottom of that. It's almost up to the bottom of your soffit. So the final kind of drawing for that solution looks like this. Hangers on all these existing joists, and I do think you probably may as well just reuse those. They looked good to me, and they are undercover. So if everything else is fine, I would be reusing those. And they get cut off just about 2 inches with the hanger there. And this is the new hanger hanging that beam on the column with the nail count. And then these are these existing footings here and here too. That's how that solution looks in a drawing at the end. But if all of these, if you want to eliminate that center column back there, if all of those are changed to 16-inch LVLs, you get rid of your center column, and you end up with about 87 inches, 7'3", underneath those 3 16-inch LVLs. And I assume you'd only do that if you took those the ones you already own, if you took those down from that gable end and reused them down here, because it is dry under there, so that would be acceptable. And then if these 16-inch things are used, eliminating that center column, instead of using a hanger down there because we just can't anymore, it's too heavy a load, 2x6s are nailed to the side of this existing column, because that footing is still, even with increasing the load out there, that footing is still adequate to carry that. So that's how that 16-inch would be approached. But that was the solution for adding the beam back there, and you already know, the other solution is to run these all the way back. And the problem you get into with that is that those things, the bottoms of those, as they are, because they're 2x8s, and I imagine they made them 2x8 so they could cantilever them out this whole almost 3 feet out here, is now 2x8s won't sit on that wall plate in there. You would have to replace those with 2x6s, and then that cantilever would have to be shorter as far as that goes if you wanted to use this solution, because that's about it, really. That's about all you could do. For now, I'm assuming that this is going to be the solution. Regardless, however, which of these, now there's 3 solutions back here. One is extending those joists back in here, but that's really unviable because you also would have to replace those 2x6s, which would change your overhang. So you're down to really this as a solution, this or the one with 16-inch LVLs back here. So having done that, gone that far, I want to take a look at this beam A here, and just because a couple things really. For one thing, this is the drawing for that where they showed the 3 columns, but they also, notice they show 6x8 girder, which in those days would have been 3 2x8s. And I think we've pretty much confirmed that those 2x8s are not bearing on top. Those middle 2x8s are not bearing on top of that thing A, and they've got funky splice conditions B. So particularly because we want to add on to this deck, and I know there's little way that I'm going to get around putting additional weight on here, unless we're going to do something really crazy with cutting this existing concrete. So having known that, and then looking at this where they show 3 of these across, and now these guys, when they build it, are showing 5 across, and this is that end one, and it's not carrying a lot of load, but I seriously doubt that there's any sort of thing beyond this slab here holding that. I kind of wondered whether they might have poured this 12 inches wide here and all the way down 32. If they did, that's good for all those, but this end one, that's a problem really. Additionally, with regard to this existing system here, these 4x4s and 2x8s, these bases, these are not fastened to the ground, at least as far as I understand these and have used them. So those ought to be, if this system is replaced, if these 4x4s, certainly if these 4x4s and that 2x8s at the top are replaced, then these bases go to something that bolts to the ground, a Simpson product or an Osco product, or something that bolts to that concrete. Going back to the drawing of that deck from when it was done, just trying to find something that we can rely on, there's not a lot. Because another thing, they show this, the center line of this, they show this on this, you can't see it here, but they show that roughly 8'10", and they ended up with closer to 9'6", so they pushed that out as well, and they got rid of these stairs. Here they show these 3, which is initially what I was wanting to see if I could rely on, and then they show, I don't know, 1, 2, 3, then it looks like they looked at a 4-column solution built further out, about to where they ended up. So it's kind of willy-nilly, and whatever I show you is going to be based upon some assumption about what's happening down through here. Probably, though, the most reliable thing you can do is replace it as it exists with new 2 2x8s, and I would just splice all of everything. Well, I would just alternate the splices through here, but these ones that have this cantilever at the end, those will have to at least extend from here to here, So I would show a splice diagram for what I'd like to see happen if this is replaced. If it is replaced, we get rid of this worthless middle one and replace that beam with two new 2x8 Southern Yellow Pine. And I like to just do it so that it's 3.5 inches thick. Is put a layer of 1/2 inch treated plywood between those two 2x8s. And then instead of that funny bolted system, I would just use these connectors up here at each of those connections between the column and the beam. The new 4x4s coming down through here, and finally new bases. And these are the least expensive base that has a 1-inch standoff and bolts to the ground. Here these caps are, and you can see that 1/2 inch plywood is not necessary. So if you want to, I will probably just eliminate that and use the two 2x8s with these connectors, two of these connectors at the top of each. And these are the bases, the ABA 44. That anchor is just 1/2 inch diameter Simpson anchor, probably 4 inches long, and I'll specify that holds that to the concrete. Because though I know that I'm going to be adding on to this deck and adding weight to this beam here by coming out here with some additional member, and it looks like, reasonably that's going to be the least we come out at that central portion if we're going to avoid cutting this existing concrete slab. We'll be coming out here with some sort of a new beam out here. And because I knew that was going to happen, we're going to be putting additional load on this. I want to design this for that as well, and we're still kind of relying on whatever exists down there for a footing underneath each of these 4x4s, and there's no way around that unless we're willing to cut that concrete back and just install our own whatever foundation we end up thinking is the best specification for that. Because we think this might be 12 inches wide, maybe it's 18 inches wide, we just don't know. The next thing, since these are going to be replaced, if you're going to add any additional load to them, is that I would just, if I was doing this, I would be just ignoring that concrete in that existing build, and I would just be moving that whole assembly down 14 inches. And this time this plays, them using 2x8s is good because those still pass at that additional length. Beam B, however, with this increased span, beam B now fails with 3 2x10s. So that beam would need to be increased to 3 2x12s. Additionally note, it has to be Southern Yellow Pine number 1. They are not passing the number 2 in their list of solutions. So those have to go to 2x12 Southern Yellow Pine number 1, and that clearance then will go down to 7'8". So those become 3 2x12s there. This span is increased. All of this is not here. These old ones go away. And moving this down to 14 then allows you to put in as much as 16 inches. Now by the time we design everything, if the load turns out less than that, we can move it back a couple inches, and these can only be 12 inches square or whatever footings going down. But certainly 16-inch footings are going to handle anything that we're going to do through here. So that much, since that's all going to be replaced anyway, this concrete is easier to cut and more reliable because we don't know it. This might be 30 inches thick everywhere through here. But if you can test that in some way, then we would just leave it back there and build on that. Otherwise, I would think we would move it forward, and I would think we would, because we know that this is going to increase to at least 2 2x10s, particularly if we reduce the number of columns from 5 to 4 or 3. We would start from the idea of getting rid of these 2 columns here, these intermediate columns, and trying to get by with 3 columns set up like this. And well, definitely these edge ones would be, situated up something like this, which certainly solves the issue at this end that I talked about earlier, and that would make the most sense probably. So that's that's what I'm going to. We can leave those back there, and you can replace them back there if you want. But if it were me, I would be cutting this concrete and putting new footings here as needed when I go to the expense of replacing this beam and those 4x4s. Hopefully then you aren't into the hardware and 4x4s for those ones here. Hopefully you're only into 3 of them, and this is more open. But I haven't designed that beam because I haven't designed what is adding onto here. And I realize we are going round and round here. I'm just trying to get to something that will work. And this back beam B, begins to become so chunky. And I know that this is carrying a similar load by the time we're done adding what we add on here. So that's going to become chunky as well. So I am now going to just try to design your system with two columns back here that are the one, 2 columns back here, and hopefully we can get by with 2 members instead of 3. And then out here we'll have 4 columns, 1, 2, 3, 4, and hopefully that makes everything a little bit more balanced and not so chunky, and is able to do it. So the idea is that there will be 2 4x4s back here instead of this one 6x6, and there will be 4 4x4s all the way across here. So that's the first thing I did, is added these additional columns, made everything 4x4s, and spaced these evenly. Presumably then there will be 2 more at least down here for a 3rd beam, so that we can extend this deck like this. So doing that enabled this to go from 3 2x12s to 2 pieces of 2x10, number 2. So that was, I think, the way to go on that. And now the 16-inch by 16-inch footing becomes required. It's right on the limit, so that much is needed. These might even move a little closer together, maybe 9'6" or so. But that's how that rear one is situating up now. These are both going to become smaller pieces of hardware, and I suspect when we start adding on down here, hopefully I can get by with 2 2x12s here, so everything can be kept 4x4s and 2 members wide. Finally, I'm ready to start looking at how to expand this, or what the opportunities are to expand this deck. And just to familiarize yourself, these are your 6x6s at the corner, ignoring that extra one you have down here. These are the 6x6s at the corner. This is that existing flatwork, that existing piece of concrete down there. And your roof is this green line here. And so in terms of expanding that deck, and I wasn't, you may have a different idea, and you can feel free to send me a sketch or update me however you like. But in terms of expanding that, it seems like this would be kind of the natural way to go, where we capture those 2 columns, bring our joists out and capture those 2 columns, and use a hanger here, an angled hanger, against this face of the column here, with a beam coming out and a beam coming out, and then some beam in here, and it's probably going to be 3 columns. Then with these joists coming out and cantilevering over that beam. So that adds the length, it stays that wide, but even at the corners it's going to add a couple feet, and at the maximum depth out here it's going to add maybe 8 feet, 7 or 7.5 feet. So the earliest you can get, unless you're going to cut this existing concrete slab for these new footings, this is the earliest you can get your beam in, is out here, which is about 8'4" from the existing one. And if we leave that there, obviously these things here would have to, if this is where it is, then this is going to probably come out like this with another one. And I know this is getting to be a lot of columns, but I'm pretty sure that's what it would take at this point. I'm going to look at it right now. But I know this is already a lot more than you bargained for when you telephoned me out there, so I'm not going to spend a whole bunch of time. But if the beam is located there as close as it can to this slab without cutting that slab, then you'll be able to cantilever your joists 32 inches maximum like this, and have that pass code with that beam located as close as it can there. And I'll size this beam and see what it takes to do it with 2 columns or 3, but we're obviously not going to be able to align these columns with these ones unless we go in to start adding additional columns back here. So right now, as it is, this solution with this expansion requires 9 new footings, all 16 by 16 by 32 deep, and then a number of these 2x10s. I'm going to size these beams now if we made the expansion like this, just to help us get through this. Actually, that deck expansion would look more like this, with this angle coming back right at the column. So this would be the maximum deck expansion. I mean, you can go as wide as you want, I suppose, but coming out, this is the maximum. This is the earliest we can get that beam in. This is the maximum cantilever overhang here. That requires, this board here is over 11 feet long, so that requires 12 footers. And if you wanted to, if you didn't need that much space, and you reduce those joists, those new joists that you're buying, to just 10 foot long, and then you have a shape more like that. So just that is kind of what I'm going to design, because I don't want to design a whole bunch of stuff until you tell me what you actually want. But this here seems to be a decent balance between the material you have to buy and what you're getting. This puts about 4 or 5 feet out from underneath the roof. So I'm going to design this and see what these members, what this member and this member becomes, and what kind of column alternatives we have through here. And as I suspected, when it was all said and done, this was not being, we were not going to be able to do this with 3 spans unless we went to an LVL solution. Actually, I was wrong about that. 2 2x12s, Southern Yellow Pine number 1 only though, will do this. Otherwise, 2 7¼ inch LVLs will do it. But regardless of which of those 2 solutions you use, the 2x12s or the LVLs, the next thing is that this load is too big on these 2 16 by 16 footings, these ones here. So these 2, these need to be increased in size from 16 by 16 to 16 by 32, which will then, and these are still 16 by 16s out here in the corners, but these ones have to be like that. So I know there's a lot of saw cutting, and I know for a fact that this is way more than you bargained for going in. But that's where we are so far. So we arrived here, and there are your new footings in the darker gray, 9 of them, with 9 new 4x4s. These ones out here, a couple 2x10s. These are 2 2x12s, and what you can't see back there is a couple 2x10s. So at least by this so far, this will enable us to extend this deck. We're able to expand it like that, and I'm not going to bother right now until you tell me where you want to go with this and how soon you want to go with it. I'm not going to bother drawing railings in here and that sort of thing. But this would get a structure that would pass code and carry the 40 pounds per square foot required with the members that I've described. This would be a special hanger here and here to hang a double beam. A double 2x8 would come over and sit on this beam C down here. So I'm afraid that's the best I can do right now. Certainly it brings you further along than where you were before, even if you didn't arrive where you wanted to. But let me know. As I said, this could probably, if you were willing to buy these longer too, if you wanted more space yet, and if we go to the floor plan on this, And if we go upstairs, this is how the edge of the deck finishes out like this. Those green lines are the roof planes over. And this is how far your deck comes right now, this line here. This line here. About that, I didn't actually measure that overhang, so that's a little fungible there. But in any case, this at approximately 8 feet to the end of it for almost 19 feet depth upstairs on that deck. So I'm going to leave that at that for now, and we'll talk on the phone or whatever after you review all this data. So thanks very much, and I will talk to you soon. I guess a few additional comments. Once I started rotating this around, it does seem like an awful lot of columns, but perhaps it's just because it's so wide, because those columns are still spaced roughly 10 feet apart, side to side, and 8 feet front to back apart. But I took a quick look anyway, and to eliminate some of them columns, if you took beam B, which is the center beam, and reduced that from a 3-span to a 2-span, even then it's going to take 3 LVLs, 3 9¼ inch LVLs to do that center beam and eliminate just one of those columns. As far as this end beam, it can't be done with anything but LVLs, and now it's out in the weather, so you'd be into treated LVLs. And additionally, when you start eliminating columns, you start increasing the size of the footings that are going to be required for the columns that stay or that remain. So, and actually, it occurs to me, so much that's under roof, you could probably enclose, and that's why I've aligned some of these columns, you could probably enclose a portion of that, particularly those, I see those 4 east columns in the center. I could easily see some sort of an enclosure happening there and possibly all the way over. But that would be up to you. I just wanted to add those final kind of thoughts to this. So that is it for sure. Hopefully this didn't put you to sleep, but I will talk to you when I talk to you. Thanks very much.